The broadcast is now starting. All attendees are in listen-only mode.
Good morning. It is 10 a.m. Mountain Time. Time to begin our webinar titled Field to Aerial, Closing the Loop. My name is Ryan Pearson with Electronic Data Solutions. I wish to thank each of you for taking the time to join us this day to watch this webinar. We do have a larger group participating in the webinar this day. For that reason, everybody is placed on mute just to avoid any background noise interference. We do, however, wish to answer any questions that you may have during today's webinar. So please, in the GoToWebinar tools on your screen, use the question dialog to pose any questions that you may have. At a couple times during today's session, I will have time to stop and answer those questions that are posed using that question dialog. With that introduction, let me just start by saying today's webinar is being recorded and will be available in a short amount of time following the webinar from our website. So if you wish to review this information or to share it with colleagues, this will be recorded and available for viewing at your convenience. Today's webinar does include a short PowerPoint introduction, just highlighting the points that I will be demonstrating. The majority of today's presentation will be spent demonstrating software tools designed to help manage aerial pesticide applications in a timely and efficient manner. With that introduction, we'll go ahead and begin with this PowerPoint introduction to our webinar this day. We will be talking specifically about a software product that we have developed for managing mosquito control operations called FieldSeeker GIS. We're going to be talking about a subset of tools in FieldSeeker GIS designed specifically to manage efficiently your aerial pesticide applications. In traditional mosquito control operations, aerial pesticide applications can be expensive. You're paying for either the use of a organizationally owned airplane or leasing an airplane, paying for a pilot, of course, the cost associated with the pesticide products, and also some ground operations to assist. Not only is it expensive, but it requires many resources for aerial pesticide applications. Lastly, any type of aerial application can be very publicly noticeable and often can be very high profile. One example would be the aerial operations 2 seasons ago in Dallas County and surrounding area in response to a high incidence of West Nile virus in the area. Very publicly noticeable, lots of feedback from the public prior to those aerial applications. So there's some unique management requirements and circumstances surrounding aerial pesticide applications. The tools I'll show you today are designed to help quickly and efficiently respond to conditions on the ground that would require pesticide application from an airplane. With aerial applications, it's very important to be efficient. This means being able to respond in a very timely fashion to field observations. By field observations, we're talking about adult mosquito trapping, larval surveillance, and species identification, disease surveillance, and even responding to customer service requests. All of these are in the field observations that will help determine where aerial applications may best be used. Once these areas have been identified for possible treatment, it's important that a supervisor or manager is able to review those proposed treatment areas and dispatch the necessary resources to complete those projects once they're approved. And then, of course, once that aerial treatment has been approved and resources have been dispatched and the job is done, it's important that you're able to quickly and efficiently record those aerial operations, including flight lines and pesticide amounts that are used during that operation. FieldSeeker GIS is a web-based software solution designed for managing mosquito control operations. Part of the tools include software utilities to manage and record pesticide use from using a variety of methods. So this could be ground ULV for adult control, it could be ground larval control, or it could be also, what we'll focus on today is the aerial adult and larval control. FieldSeeker GIS now does integrate with aerial guidance systems, so we can, using FieldSeeker GIS software tools, provide spray areas or proposed treatment areas to pilots that they can use in their navigation systems, net guidance systems for making those applications. And then that data can be brought back into FieldSeeker GIS. That's the portion we'll be demonstrating today. So with that short introduction, I want to actually switch quickly and begin to show our live demonstration of this technology. Prior to that, I have a couple poll questions that I would like to ask the attendees to respond to. Let me just start by launching this first poll. I'm interested in how many of you are currently using aircraft for applying pesticide, whether for adult control or larval control. So let me launch this for you. Please take a few moments to respond. It's a very simple poll. It's helpful for us as a development team to know if people are using these tools. We'll give a few more seconds for people to respond. It's an interesting breakdown right now. About 75% of the attendees are using aerial spray methods for mosquito control at this time, while 25% are not. We'll give just another moment here. We're still waiting for a couple of people to respond. Yeah, there we go. It's just changed to 80% yes, they do apply product to control mosquitoes via aircraft. 20% do not. I'm going to go ahead and close this poll, and we'll move on to the. Well, let me ask a second poll here real quick that relates to this first one. We do have 20% who do not apply product via aerial applications. However, I'm interested in those who responded in the affirmative, whether or not you're using software for managing those mosquito control operations at this point. So here's the second poll that I would like to have you answer here real fast. If you do use software for, or excuse me, if you do currently apply product by aircraft, do you have a software program for managing and recording that data? And so far, 100% have responded in the affirmative. Now it's 80%. Select no. Excuse me, I meant no, not in the affirmative, but no. 20% have it in their future plans to do that. So to show those results, 80% replied in the negative. They don't use software for managing aerial applications. 20% have it in their future plans to use software for managing aerial applications. I'll close that poll. We'll start this demo here real quick. Let me back out of the PowerPoint presentation. I'm going to pull up my web browser here, showing our FieldSeeker GIS software application. For those unfamiliar with FieldSeeker GIS, it is a web-based set of management tools for mosquito control operations. It has some simple navigation functions, being able to just simply select the map and drag it for panning to different areas. Just what you would expect with a web-based mapping system. In addition to this capability, we have the tools to manage our background maps, for example, just some things you would expect to see with a web-based solution. So if I wanted to show an aerial application of the Florida Keys in Florida, I'd be able to pop over and change that background map nice and quickly. For this demo, I like that dark gray canvas because it better illustrates what I'm trying to show. I'm going to switch back to that dark gray canvas which we were using initially. What we're looking at here is just a simple navigation tool where we can turn on our background maps, manage the view in our maps. For example, I can pull up my table of contents and turn on information that I have invisible at this time. For example, I can turn on my adult mosquito trap results. You can see on the map dynamically triangles have appeared that are scaled to size based on the number of mosquitoes trapped at that location. So there's great interaction, great capability for customizing this map that we're looking at here. For this purpose, I want to show some additional tools that a supervisor might use. Over here on the left, we have the ability to generate reports, for example, chemical use reports. On this left-hand side, we'd be able to look at product inventory, how much pesticide we have of different types, both in the warehouse and on the vehicles. Some laboratory tools for managing our mosquito trapping operations, for disease testing, for tissue sampling. Those types of tools are available over here. In the map, I do have some layers turned on that are specific to aerial applications. So in this map, we're looking at, in the blue, some flight paths. Some flight paths from aerial applications. I can click on any of these and we can find out the aircraft number, who the pilot was, what product was used, and the date and time that application took place. So I flew into an area of the Florida Keys where there were some aerial applications done back in May to control mosquitoes using Dibrome. I'll be showing you how we actually create these areas, these spray zones, spray blocks, assign this work to a pilot, then get the results of that spray operation back into the system so we can view it like we're doing right now. So let's start by talking about the workflow. I'm going to zoom out here and just go into the Key West, where there's a lot of surveillance data. By that I mean a lot of customer service requests, larval inspection data, and adult trapping information. So let me zoom in here to an area of Key West. And I'll probably turn on some layers here so I can see the trapping results and outstanding customer service requests, some of that type of information. Let me turn on some layers for trap results. So here we can see that there's a lot of trapping in the downtown area, which has received an aerial spray treatment this season. These basically, these diamonds, or excuse me, these triangles scale up in size based upon the number of mosquitoes that are collected at these trap locations. In addition to turning on trap data, I want to also look at customer service requests and landing count data. So I can turn on some landing count data. Similarly, the landing count data are scaled up in size based upon the number of mosquitoes in those landing count studies. And then I'll turn on my service requests. Basically what I'm doing here is looking at clusters of service requests near high mosquito populations, either trapped or through landing counts, to identify a treatment area where aerial application might be a suitable treatment option. So we do have lots of customer service requests in Key West. Let's go ahead and zoom into this area up here where we have a large number of landing counts as well as a cluster of service requests. So I'm going to zoom in a little bit tighter here just in this area to give a better view. We have this neighborhood here where there's some larger landing count numbers. There's clusters both here and down here of open service requests. They don't have a lot of trap data for this area other than down here in this corner near this cluster of customer service requests. As a field technician, I may look at all of these results out in the field, the landing counts, the customer service requests, trap data, and I may determine that this area might be most effectively treated using an aerial application. So I'm going to go ahead and show a tool on the desktop where we can create a proposed treatment area. A field technician has the opportunity to create a proposed treatment area, assigning it a treatment date and priority. That data is then reviewed by a manager or supervisor in the office before that spray request is actually submitted to a pilot for completion. So I'll show this first in the desktop, how we can create a proposed treatment area. I'll then switch over to an iPad device, a mobile device that might be used by field technicians, and show you how we can create these proposed treatment areas using a mobile device as well. So I will show how to create a proposed treatment area within the office on a desktop PC like we're looking at now, and then I'll repeat the process on a mobile device that would typically be used by a field technician to do the same thing. So I'm going to come into my proposed treatment area options here and show you some proposed treatment areas that have been created already. These are proposed treatment areas. Let me select a one that's been assigned for aerial aircraft. This is an example of a spray request or an aerial treatment request from a field technician. As a supervisor, I can edit or review that data. It shows up with a site ID, what map area it's in, how high of a priority it is. These are drop-down lists where you can look at this, determine what the priority as set by the field technician was, how many acres in size this proposed treatment area is, and the method of treatment. Not only can we use proposed treatment areas to manage aerial workflow, we can also use it for truck type operations, other types of or methods of product applications. This is an aerial workflow. I just want to show an example of what one would look like when a proposed treatment area is created before I create one. So I'm going to cancel out of here, not make any changes to that. Let me come over here, and I'm going to show you how to create a proposed treatment area. I'm going to press Create Location. I can create many types of locations in the office, but I'm going to create a proposed treatment area. I'm going to select this box, and now I have the ability to create a proposed treatment area just by drawing on the map. Kind of follow this road here, just come around this neighborhood. Once I'm done drawing in or using GPS to identify a proposed treatment area, I do have to give it a name. I'm just going to give it a name where I can later remove it, calling it Ryan's spray block. I'll choose my name from the drop-down list of field technicians as the person who created this. Long list of names here. Let's go ahead and choose Chad from the list. I thought my name was that list, but it's not. How are we going to treat this site? It's going to be an aerial application. List of priority. We're going to say that this is a high priority. We want it done today, 10/29, 317 acres in size, and just say lots of adult mosquitoes in the comments. I can save that. This will then appear on the map. You can see the diagram that I drew in here. If I come back into my proposed treatment area utility, it will appear in this list. Let me change that here. So here's one created by Chad, 317 acres in size, lots of mosquitoes. This is the one I just created that can be reviewed by a supervisor. What I want to show now is switch and show you how this would be done on a field device. Let me get logged in here. So here's an iPad that might be used by your field technicians that uses the same tools that we just saw on the desktop. I'm going to zoom into a neighborhood here. Zoom in over this way. Once again, I have the ability here to choose layers, backgrounds, base maps. I can toggle between different things here just like on the desktop. But I also have the ability to create a proposed treatment area, and that's what I want to do now. Just using a button at the top, I have the ability to create a proposed treatment area. We're going to draw in a partial area rather than selecting an existing spray block. We do have the ability to use existing spray blocks that exist. I'm just going to draw in this area a rectangle showing an area that we'd like to have sprayed. Once I'm done, I can actually come in and pull up my form, give it a location name. When it's due not the 22nd. We're going to do it on the 29th in the PM. It's in the Northeast 02 zone. It's on Island 11. Priority, let's set that to a critical priority. What method are we going to use? This will be an aerial adulticide operation. Could be aerial larvicide. And then any comments. When I'm done, it will be part of the record here. This will now be available on the server for a supervisor to review and then assign to a pilot. So let's get back to the desktop and show you that process. So on the desktop, once a proposed treatment area has been identified based upon field observations, a supervisor would use these proposed treatment area tools to review these proposed treatment areas. We have the one that I showed you a moment ago. Let me go ahead and choose the due dates and sort this. The one that I created for Chad will zoom to that location. I've selected it in the list. I can zoom to that location both on this pop-up map and the map in the background. It highlights it so I know where it is. I have the ability to actually review that information. So this list called Ryan Spray Block is created by Chad. It's 317 acres. If this looks okay to me and I have the resources, the weather conditions are right, and I have the resources to complete this mission, I can then just press this Export to Shapefile button, which would create a file that can be loaded to those navigation systems, both SkyTracker and AgNav are the two we support currently. When I press the Export to Shapefile, it just creates a file that would then go to that navigation system. The pilot would then complete the mission. And once that data comes back from the pilot showing our flight lines and the amount of product used, we would go to our Enter Treatment button, enter those treatment data. I need to choose our treatment again. I didn't have it selected in the list here. Let's go ahead and choose this one right here. Press enter treatment. This is where we record what product we used, the dates and the time of the beginning date, end date, beginning time, end time, what spray area, who the field technician was, what product we used for the application. I'm not going to enter that data here because that is a real spray request I just clicked on. So I don't want to show it as being completed before it's actually completed. Let's come back to this one that we created for Chad, my Chad. Once the operation is complete, we would just press the complete button showing the date and time it was done, excuse me, the date and who it was completed by. So there's the date it was completed. It was completed by John Carson as the pilot. Press complete. That's going to be removed from the list. We do have the ability to actually review the completed treatment areas for the last 7 days or any number of days. I wanted to show that. Once the product or the process is complete, I'll show you again what the results look like. I don't have, for the demo, any data to import from SkyTracker or AgNav. So we'll go back to one of these other keys that has a lot of aerial applications completed. You just click on any of those and it will show you who the aircraft was, who the pilot was. This is the data that comes back with the flight lines from your pilot. You can see each of these flight lines. You can click on any of them at any location, and it will give you the details of that spray operation, date and time it occurred, aircraft, pilot, and product. In the reporting mechanism, you also see how much product was applied in each of these. So there is a very nice set of tools in our reports. If I come to my report utility over here on the left, this is actually going to the Florida Keys server, and I don't have the username and password, so I don't have the ability to access their server to actually generate the reports at this time. This would be a report server where I could filter for aerial applications and date ranges and even spray blocks. And this would bring up a report of exactly what was done, how much product was used, and by whom. Anyhow, we're running out of our 30 minutes. I do want to reemphasize that you can ask questions in the questions pane. I'll answer those at the end of our session if there are questions that are asked. I do have a couple slides left with additional information. So just to summarize what we've looked at today, the tools I've demonstrated in FieldSeeker GIS are really driven by the field observations. These drive the control decisions, whether to initiate ground-based control, whether it be ULV or larval control using various methods, or also what I showed today, using these same field observations, whether it be service requests, adult trap data, landing count data, or disease surveillance data to initiate aerial applications of product or mosquito control. The tools on the desktop allow field supervisors and managers to efficiently review and assign those aerial applications. These can be assigned to specific pilots or to specific dates to be completed by whomever is the pilot that night. The tools that we've developed in FieldSeeker GIS do integrate with application navigation systems, both AgNav and SkyTracker currently. FieldSeeker GIS, through the reporting mechanism and the map integration, quickly make available these application records, either visually or through a tabular report. What we looked at today is just a very small set of tools available in FieldSeeker GIS for managing mosquito control operations. FieldSeeker GIS is a comprehensive set of software for managing mosquito control operations, from surveillance activities, just responding to service requests, managing ULV operations, and all your surveillance activities as well. The tools I demonstrated today are just a small subset of our larval and adult mosquito control tools. We do have other webinars available that will demonstrate more of this functionality, more of the functionality of this software. Here's a sample of some of the upcoming webinars over the next 2 months, looking at the advantages of GIS-centric systems versus map-enabled systems, the use of unmanned aircraft systems and vector control, using ArcGIS Online for both status maps and also operation dashboard, using ArcGIS Online to manage service requests, and then Sentinel and FieldSeeker, not just for mosquitoes. You can register for any of these webinars, upcoming webinars, using the link that I have below. With that, I want to open the webinar here to any questions you may have. Please use the questions dialog, both found in the found here in the GoToWebinar tools. Just go ahead and type those in. We'll wait for a few moments before closing out this webinar to see if you have questions. I do want to re-emphasize that this webinar is being recorded. It will be available for review shortly following the conclusion of today's webinar. We'll just need some time to convert that recording and then get it posted to our YouTube channel for review. Okay, it doesn't look like we have any questions. I'm just grateful for the opportunity to demonstrate these software tools. There is a question that came in. Let me answer this first. It says, can no spray buffer zones be included in the shapefile? The answer to that is the way it works is that we would export the spray block or the proposed treatment area in a shapefile, which would be the area that would need to be treated. We would export a second shapefile, which would be the no spray zone that may fall within that area. That's no spray buffer. So to answer the question, we can provide both the no spray area and the proposed treatment area in shapefile format. They would, however, be in separate shapefiles for aerial application. The other method we could do would actually be to customize that spray zone to, or excuse me, to customize that proposed treatment area to exclude that no spray area within that proposed treatment area. So to answer the question, we can do it. It would require either exporting two shapefiles or customizing that proposed treatment area to exclude specifically that no spray buffered area. We're excited to offer these tools. These are relatively new tools for managing aerial operations. That's why we wanted to demonstrate this functionality in a webinar and also describe this functionality in a blog post that you can review at electdata.com. We will have these upcoming webinars that you may join us to learn more about the advantages of a GIS-based system for managing mosquito control operations. With that, I wish to thank each of you for taking the time to join our webinar today. We do value your time and appreciate it very much. Thank you. Have a good day.